Hello, everyone. Yeah, to give you some context for Pacific. So cephadm in Octopus is fairly new. So we have still a lot of rough edges, and I think if people are actually starting to use cephadm, they will find a lot of gaps, a lot of bugs. So from my perspective, we should focus for Pacific mostly on fixing bugs, solving gaps in the workflows, instead of really adding new fancy features. At least that's the focus that I would like to have for Pacific. Yeah, and with this, let's get into the meeting minutes. So I hope you all have the link to the Etherpad.
Mm-hmm. It's in the chat.
Yeah, perfect. So if you have any discussion items, then feel free to add them. So one discussion item is, of course, the day one experience, which is the first discussion item. Describe a cluster in just one file uses to create the complete cluster. I think at least for cephadm, we've solved this already using the pull request, which is kind of generic and should also work for rook, at least partially, with a very reduced feature set. So that's mainly aimed at cephadm, of course. Any questions, any remarks regarding the one experience for cephadm, for rook, etc.?
I wonder if we should add an argument to Bootstrap, like input spec or something like that. By spec. That way it would literally be one command that would just that would bootstrap and then also apply all your other stuff.
Yeah, right now you have to do two commands, right?
Steps.
You have to bootstrap and then.
That's it. That was my question. If everything can be joined in only one command, just to provide the cephadm parameter, the file name of the description of the whole cluster, and cephadm start the bootstrap cluster and then apply the rest of the specification.
So reading a config file, right?
Oh, no, you're not. You're right. Yeah.
You're only adding the local host and not everyone, any other hosts.
Yeah, so I actually, somebody has a point here that we also need the host add stuff. I wonder if you're like a host map or something like that, host list.
And then and then we have to add labels as well, host labels.
But yeah.
So I think it does make sense, right? But we have to carefully design it.
Yeah, just to put some context on this, okay? I have been talking with OpenStack people this past week, okay? And this is one of the features that they would like to have, okay? To have only one file to describe the cluster, the whole cluster. And well, even they wanted to have this file like a declarative description of the cluster, okay, in order to keep the cluster with the same status always. Just,
yeah, have a look at the pull request that I've linked.
yes, I have seen. Thank you.
That's mainly everything you need, except for
yes, the bootstrap and the host addition. Yes, I know. Okay.
Yeah.
Should we create a YAML file for a host, like host name, address, labels?
Oh.
We already exposing that when doing host ls -- format equals YAML.
Yeah, it makes sense for it to be YAML, I think. Would it be would the spec accept it? I wonder, for all the labels. If you do, what is it apply -I? Is that the thing?
Yeah.
Okay. Yeah. Yeah, might as well just sort of look up everything.
Then we actually do have only one big file.
Yeah.
And one command to apply it. That would be interesting.
Cool. I don't know how many people will really do that, but I don't know. Yeah, it'd be pretty nice. Single command, boom.
This is something that we would like to do.
Cool.
Support. Okay, so vstart support already exists with the cephadm argument.
Yeah.
And actually, I'm working on updating the kubejacker script right now. I'm renaming it cpatch and just letting you pass arguments, making it a little bit cleaner and more streamlined. And I think actually combination of this and the cephadm thing should let you pretty easily develop with a local cephadm vstart, build your own code, generate a local container, and launch Newmans.
Wouldn't it make more sense to mount the binaries, mount the libraries, and mount the manager modules into the container instead of building a new container image?
If that's possible. I think then cephadm would have to be all changed up, right? Because it would have to, like, if we get rid of that container as the sort of generalizing point. I don't know. It is a little bit slow to generate the container. Like, it takes maybe a minute to copy a bunch of binaries around. But I think that's still a reasonable turnaround time if what it buys you is the ability to like run something of RGW specifically, like running multiple RGW zones and so on. If we can get all the developers using the Orchestrator workflow in their development and testing, then that's going to force, A, it's going to make sure everything works, and B, it's going to focus everybody's attention on the actual user experience.
Who's going to take it?
Oh, I'm working on it right now.
Oh, cool.
I should have a pull request later today. I think the main caveat here is that it works on my machine because I just put CentOS 8 stream on my dev box, and so it matches the upstream container image, and so everything just works. If you're on a different distro, then you have to do builds inside a container. We have to figure out that part of the workflow.
Mm-hmm.
But maybe that's a reasonable price to pay in order to do this. Develop on CentOS. or get an upstream image that you can base it on that's based on whatever your distro is. That would be it. Anyway.
Does that just mean the first time build is slower than the subsequent ones?
Well, presumably there's a way to build in a container that I haven't tried yet, in which case, yes. But so the way that cpatch works is it takes the upstream image, it just pulls it from Quay, and it just copies stuff from your build directory on top of it. So it's the distro just has to match, basically.
Cool.
I think there is a how to build def within the container, mount the source directory, build within the container, and then it works. I've tested it.
Okay.
So
maybe
many
just
months ago.
running that would work. Yeah, that would work too. Because then, you just do your build directory would basically be distro specific. That makes sense. Yeah. Okay.
Okay. So, are there any other cephadm related discussion items? One can think about tautology, for example, right? In improving the tautology integration, but what would be the point?
Sorry, say it again.
Services for backport.
Sorry, you were saying tautology support for cephadm?
Yeah, we have that already. What would be the next steps?
So I have a PR that lets it sort of PR that makes it managed. So the tautology isn't carefully placing daemons. I think works fine as long as you're not doing thrashing. It works with the Osd Thrasher, but not Mod Thrasher. Although we could probably make it work with the Mod Thrasher too. We haven't tested the Osd Thrasher, actually. In principle, it would work. I think the main thing is client workloads. We want to deal with that. I mentioned this yesterday. Either run them inside a container, host, which is packages, etc. Generate a ceph debug container that adds bug info and so we could build another container image that just has all that crap in it. That might be the simplest thing to do. Or we could install this pack. Or because every time you do a test, it would have to do the same thing versus generating one container image once.
Okay.
But yeah, once we
Great.
do that, then we can convert a lot of the Redis suite over to utilizers.
Okay. Services for backport.
Okay, so I was just thinking NFS is a work in progress, but once it's done, we should backport it. iSCSI is also in progress, and it kind of feels like any of these things that we add when we add support, we might as well backport them because we're sort of aggressively backporting everything.
So,
and sys is the one that I'm sort of intrigued by because we haven't started that one yet. But he could be eager to use it at least.
Right now, I would like to backport every pull request to Octopus, and until at least, yeah, for the next few months.
Yeah.
And then keep the sources identical between Octopus and master to make it easy to backport everything back to Octopus.
Yeah.
The encrypt. There is an issue for that.
Does it open? Okay. Yeah, we just need to figure out why it isn't working right, I guess. Sebastian, did this get tested with Ansible containerized stuff? Do you know? Dencrypt
Which one?
OSDs?
Yeah,
Creating
it
OSDs
is.
with encrypt, and it worked?
Yeah, it is. Yeah,
Okay.
it does, yeah.
Because I was having trouble making it. I was just running, opening a containerized shell and then running cephadm create or prepare with Dencrypt, and it wasn't working. It would just hang on like the crypt setup. It would just block.
Do you have semaphore enabled on that container? You need IPC host. Well, it's waiting for semaphore, so you need to have IPC host enabled.
What is it?
It's an option when you run the container. You have to have IPC host. Yeah, IPC.
host
yeah.
equals host.
IPC equals host. Yeah. And that should work.
Awesome.
That's right.
Okay.
We had that same exact issue in Rook, but yep.
Perfect. Okay. Hopefully that'll just fix it. Hopefully that'll. I think file store is a bigger problem. When I was upgrading the lab cluster and converting it to cephadm, I hadn't realized that there are a whole bunch of file store OSDs and that support didn't work at all. And so I looked briefly at like quickly adding it, and it was not trivial. I think it's because you basically have to mount a file system that's on the device. You have to mount it at the location that's also the containerized bind or whatever. And so it's awkward to figure out where that should happen. All of the other daemons have a directory that exists in varlib ceph fsid and then the daemon ID, and that sort of is the container's home, and it's bound into the right location and so on. And for file store, it doesn't work quite right. I know it's unclear how to make it.
But it should be the same, right? What's so different with file store?
Well, because BlueStore doesn't work that way. So with BlueStore, there's a directory that just has like a handful of flat files, and then you start up the container, it puts those in the right location, and then you start it up, and they're like symlinks to block devices and metadata and so on. So it's just a file that it's something that's already mounted and exists on the host, and you bind it into the container, and then you start. But with file store, you have to either mount it first on the host before you start the container, which breaks the whole abstraction because all the units assume that you could just start the container and bind things and it works. Or the container, once it starts, has to do all that. But
it has to activate the store.
This doesn't work.
Doesn't
it? But the directory already exists and has to have stuff in it to tell. The directory has to exist and have the bash script that actually runs. So maybe that could be, but then it would have to mount over itself. Basically, whatever. It just mounts in the wrong place. I think it doesn't quite work. So we'd have to figure out. Yeah, it's awkward. It might mean changing the way that the directory gets bound into the container to be something totally different. Like maybe it binds it to a different location so that it can then activate the OSD in the OSD location or something. I'm not really sure.
How does this work for ceph-Ansible support and rook support for file store?
I think there is an activation sequence being done by a container. It is actually by mounting. Well, I have to remember, so bear with me. I think it is activating the device through an activation init container, and then the store is then mounted already. So when you start the container, then you just use that bind mount. Well, I have to look. Sorry, I don't remember how to do it.
That's all right.
I think it's not that it couldn't be done.
Just something needs to be adjusted with the way cephadm setting up.
Yeah, I mean, cephadm it basically has this assumption that that directory is the data directory, and that all containers sort of behave in a similar way, and that it maps that directory to that spot. It just happens to be the same location that you also have to mount on top of, and so it was just a bad choice in that sense.
Yeah, adding a new mount for the data should be possible.
Probably there needs to be like some file or something in there that indicates that because this is a file store OSD, that daemon directory shouldn't be bind mounted to the data location, but instead some other temporary location.
Mm-hmm.
So that then inside the container, you can mount the real thing on top. So it could be done, I guess, yeah.
In Rook, we were doing something like that for file store, but now we're removing file store support in the latest 1.3. So I guess I'm curious how much support is, or how long is file store being supported? Is it
exactly? I think critical? That's why. Yeah. Do we actually want to do this? Even if it's doable, do we want to do this, or do we want to use this as a wedge to help push people upgrade to BlueStore?
And is cephadm taking over existing clusters, or is it just for new clusters taking over?
Yeah. Yeah, it takes over.
Taking over everything.
To implement like a BlueStore conversion as part of the takeover process.
Yeah, that was the original idea, but
okay.
Well, the original idea was once we had the Orchestrator API, and so that you could reprovision OSDs programmatically, then we could write a manager module that would do a very nice and careful and smart BlueStore conversion. So.
Yeah, one of the things we've been thinking about for Redis was a manager module like that to do formats, formats or settings changes on the disk format for BlueStore, and the same kind of sequence works for reformatting as well. But does that require initial file store support for cephadm so that we can kind of bootstrap?
Yeah, I think so. Yeah. Well, maybe not. So the which just kind of leads into the adoption topic. So the way that originally the idea was adopt would take any sort of existing daemon and it would just basically rename the directories, and you would, when you restart it, it would start up in the cephadm style container. But the reality is that you only really need to do that for the monitors because they have actual data, and for the OSDs because they have actual data, and for maybe the first manager just so you actually are running the right manager code and cephadm module. But all the other daemons are stateless, so you could just delete the old ones and just provision new ones. In fact, you probably want to do that anyway so that the naming is sort of in the new style and consistent with everything else. And the inventory that cephadm fetches will show you all the legacy stuff. And so it could be that you could automate, you could do it so that the adoption process is you just literally restart the manager even, and then you tell it to like automatically adopt, and it could run. It could actually automate the process of going and adopting each daemon and restarting and all that stuff. Because right now you just have to log into every host and you run the command manually, which is sort of silly. And so if that were the case, then it could be aware that the file store OSDs are there, and it could delete them one by one and reprovision those disks as boostore, I guess. Do the conversion that way. Without actually supporting file store explicitly.
So right now that's not supported at all. So
yeah.
Just
look real quickly.
Josh?
Go ahead, Josh.
I was just going to say I really like the idea of that cluster-wide kind of take over with this like a single command in it, take over the manager, and then kind of spread from there.
Yeah.
Right now we are using sort to do that for us, for SUSE. But that's not that doesn't work if you're not using sort. Yeah. I think it does make sense to have some kind of adoption on remote servers. Yeah.
Mm-hmm. There's a to-do item to write an Ansible playbook to do it, but it might be easier to just bypass that whole integration or whatever and just do it.
Okay. Anything else regarding FileStore?
Well, do we have a decision, I guess? I think. Do we want to run?
Someone needs to take.
Yeah. We could not support file store at all. We could force. We could support adopting file store, but not running file store containerized, or we could support fully containerized file store. Those are options.
If someone wants to implement that, I would also be okay with having file store support. Otherwise, we will likely not support it.
Yep. Okay.
Okay. Resilience, independence, recovery. I think that's a topic mostly for cephadm. So it is idempotent.
What I mean is that if the user uses the same, for example, spec file or placement file for certain service, what is going to happen? And the other thing, lot of questions about that, about the resilience of the system. What is the target? For example, if we specify an RGW service with certain placement, okay, in certain nodes, what happens if one of the containers is failing? Is going to the orchestrator with cephadm responsible to restart a new container in a host, or this is not going to be one of the features of the cephadm and cephadm orchestrator?
For Octopus, we're not going to spawn new RGW on a different host automatically.
Okay, but it doesn't matter that if it is RGW or another service. What I mean is, well, you have defined the specification of the service with one or more servers, okay? placement in certain host, okay, what is going to happen if some of the containers are failing? cephadm is going to restart these containers or not?
Systemd will restart the containers if they crash. So we're using systemd here. Yeah. They're hooked up into systemd and they're automatically getting restarted. And if they're failing, then they're offline.
Okay, so it's not a cephadm the responsibility of cephadm is not to keep the state of the system.
I wouldn't rule it out for Pacific. So there is a class to actually have some kind of more sophisticated scheduling there. Right now we are just placing daemons on hosts, and then that's it basically. But we could extend it to also incorporate offline hosts and run that periodically, for example, and then place new LTW daemons on different hosts. Sure. That would be a step, yet another step to go into the rook direction, right?
Yeah, okay.
Any thoughts from you?
No, just to know what is the limit for in cephadm in order to
the limit is
until what point it should. The limit is rook.
The limit is rook. If we are going more advanced than rook, then I don't know if we are really still in the right direction, right?
Okay.
Yeah.
Okay.
Yeah, I think it might be reasonable at some point to have something that notices that a container is persistently failing and won't start, and delete it and reschedule it somewhere else. But we don't do that yet. That seems like something we can add.
Okay.
I think it's okay to sort of midpoint because it's still doing much more than Ansible did, and that's sort of what people are used to. But eventually, we have all the information we need to sort of take another step forward. So
okay,
it may be a bit less scary for users if we are not trying to be that intelligent right now.
Yeah, I think so. Yep.
Okay.
Ceph-disk is on here. Was that in the context of file store or BlueStar? Because we do
so Ceph-disk in general, also for BlueStar.
Right. So my personal cluster at home had a bunch of early BlueStar OSDs that were created like in Kraken or possibly even pre-Kraken, and I got to adopt them. It's a little bit fragile because it basically, when you do the adoption, it copies stuff out of the Etsy Ceph volume or Etsy Ceph disk, whatever, simple, that weird Ceph volume flat file thing, and puts it in the OSD directory. So it works. Once you adopt it, it'll work and it'll start. But if you were to delete that directory, and so you have a new disk, you take that same disk or plug it into a new host, I'm not sure that there's a working procedure to rehydrate or recreate a container, whatever, so it'll start. Or it might be a two-stage process where you have to do like stuff, volume, simple, discover, whatever it is on the host, and then adopt it again or something like that. But I think it's fine because these are pretty rare, these old BlueStar instances. I think almost everybody deployed BlueStar with Ceph volume, so I think it's okay. If we want to do file store, then things are a little different, because probably most of the file stores out there are actually Ceph disk file stores, or many of them. at least.
Mm.
But yeah.
Automatic adoption. We need configs in the cluster DB. Which configs?
So if you're adopting an arbitrary existing cluster, a lot of old clusters, probably most old clusters, are generated with ceph.conf files on every host to configure all the random stuff for the daemons. And when you do the adoption, it just basically throws that or ignores that config file completely and assumes that everything's already in the cluster config database. So it needs to, the first step is probably to import all those. If you look at the adoption document or whatever, the first step is to get all your configs in the cluster and then go and adopt all the daemons. I think this whole thing makes me, the whole idea of automated adoption sounds nice, but it's also a little bit scary because it's such a, you can have clusters of like any vintage with such a wide variety of deployment tools. If we do it, we need to make it, be very careful, I guess, about it. So that we don't go sort of automatically break every OSD or something.
And we need to make sure that users have a set of existing deployment tools. So we are not going to adopt random clusters.
Yeah. I guess my inclination is for now to just have people follow the documentation and then get feedback about how that process works well or doesn't work well and what the pitfalls are. And then once we have some confidence that the procedure works, then look at automating it. But I think the documentation still could use some simplification and streamlining because there's still this thing where you can adopt all the old stateless daemons like MDSs and RGWs and so on, but it's probably better just to delete them and deploy new ones. And it's hard to write the procedure to do that because it sort of depends on how it was set up before and how to mimic, especially with things like RGW multi-site where like God only knows how they set up all the different configs and so on. And
yeah. So there is at least some requirement to have some automatic adoption for at least one existing deployment tool. Having that for example for Ceph disk would be great, right? But for Ceph deploy would be great. But I don't know if we can do that, or if we just link to the documentation for Ceph deploy and that's it. I think that's okay.
Yeah. The carrot should be big enough to motivate people to do this.
Okay, telemetry, does it report outs backend? If, as far as I understood, telemetry returns or pushes the keys of the settings that were changed, right?
Yeah.
Not the values. So if you have anything written with the key starting with cephadm, then it's obvious that's cephadm.
Well, yeah, but it doesn't. Yeah, but it doesn't actually. On my cluster, there's no options apparently that have cephadm.
Okay.
Yeah, I don't think so as well.
But it'd be pretty easy to add. Yeah, the only option is Orchestrator equals cephadm, but you just know the Orchestrator set, not which one it is. But it'd be pretty easy to add this, I think. To report that it's cephadm, we could report what mode it is, maybe. Or not, actually, maybe that isn't. No, maybe, I don't know. Yeah, whether it's root mode or packaged mode. But this would be a pretty easy addition.
Okay. So do we have some time left to discuss drive groups and OSDs on PVCs?
Yeah. Yep.
I don't know. That's a topic which is a bit problematic because have OSDs on PVCs and drive groups, we can make it work, but is it really the goal to make it work?
Right, and you're asking the question, do we want to make it work? So drive groups creating OSDs on PVCs, right? Because that, I mean, I guess the way I see that we'd have to get that working is that, so the drive group request comes in to the orchestrator. The orchestrator now has to go generate PVs, like local PVs, based on the request, and then generate the correct rook cluster CR that will go consume those PVs. So it could work if the manager has an opinion about how to create those PVs and to be able to translate from drive groups into PVs and then OSDs. It's a bit complicated. It could work. I wonder if it's not worth making that whole thing work on PVCs, because then the manager has to be opinionated on how to create those local PVs. I don't know. It needs a lot more thought.
I was assuming it's actually meant a different use case where, say you are on AWS and you want to create OSDs using PVs from like an EBS storage class or whatever it is. And can you write a drive group that says create 2 OSDs per node using this storage class?
Yeah.
Whether you could.
Yeah, that use case makes a lot of sense to me too. I was thinking drive groups were about specifying individual disks, bare metal type.
Well, they are today. Yeah. This is sort
So
of
we're talking mainly about so when it comes to PVCs, I think we're talking about just specifying a number of devices in the drive group.
Oh, okay. So you're assuming that the volumes can be dynamically provisioned, not that. So we're not talking about bare metal where you're defining drives in the drive groups. You're just saying, how many do I want?
I don't know.
Okay.
The drive groups really are also great for bare metal.
There's this whole problem of, I guess, PV creation, which if you're in a bare metal environment, Rook's current position is that, well, create the PVs before you go tell Rook how to consume them. So if we can make that same assumption with drive groups, I think it'll fit nicely into Rook's model, and we'll keep it simple. If we try and bring the local PV creation into Rook, that's where I would worry more, or into the orchestrator. If we keep that assumption, dynamic provisioning with the storage class in the drive group, then that's easy to translate into the Rook CRs.
That makes sense to me.
Mm-hmm.
I'd want to hear like a pretty compelling reason why that doesn't belong anywhere else, and there's no other good place to do it. The bare metal case. Well, I guess it would be this: like if you're deploying Ceph on bare metal and you're using Kubernetes as the orchestrator, but it's a bare metal cluster, and you want to use the dashboard the way you always have to describe hardware. But then you just wouldn't use PVs, right? You would just use
right. Then you could just go. You could go straight to the old way of doing it without the PVs. Yep.
Yeah. Okay. That makes sense. So then in this general case where you have an existing storage class and you just want to provision OSDs on top of them, I think we just need to decide what the drive group looks like, because it's not, I think drive groups currently are imagined so that the devices already exist and you're just picking them and selecting them. Whereas here we have to say like create this many per host, I think, or something like that. So we'd have to just come up with a drive group syntax that makes sense.
And does it make sense to still call them drive groups? I guess in my head I had drive groups as meaning specify the hardware, but this dynamic environment or dynamic provisioning could be a different type of drive group, as long as we're clear on what type of drive group it is.
And drive groups also don't really specify the hardware. It specifies more of the attributes of the hardware. So if that helps, I don't know.
Kind of feels like we should just rename drive group OSD spec everywhere.
Probably.
In the documentation and in our brains. It's already sort of did this. Yeah. Okay.
And I guess the thing with using storage classes and PVCs is that all you need to tell Rook is basically which storage class do you want to use to create the OSDs, and then it goes and requests it. So at that point, there aren't, like, you wouldn't define really the properties on the devices we're going to go look for. You just have to tell us what's the storage class name.
And you have to tell Rook where and how many to create, right?
Yeah, basically which storage class, how many to create, and some other, you could do other properties like, do you want it encrypted or
right?
Yeah, type as well.
Like a class, OSD class, whatever.
Like block mode, or which thing, Seb?
Whether the device you will be creating is a block or a database or Blue Store.
Oh, right.
So either data or metadata.
Oh, yeah. Yeah.
If you want to split the DB.
Yeah. Data.
Well, I feel like the OSD spec could be really similar, not to say maybe identical to what we do with device sets already in Rook when we provision on PVCs. Because at the end of the day, the translation will have to be really simple. It's almost a one-to-one mapping at this point. If it's a new section from drive group / OSD spec.
This seems like a good thing. It might confuse the current dashboard stuff because the generic code in Python common and the dashboard sort of assumes that you feed an inventory, you apply the storage class, not storage class, the drive group spec, and then it tells you what devices it would have used. But this is different, right? But
in the bare metal case, we should be able to detect what local PVs are available still and feed that inventory to the dashboard. But if you're like an AWS, you don't have an inventory to discover. You're just going to dynamically provision.
Yeah. Yep. Yeah. Okay. All right. Upgrade cephadm to rook. I think you're muted, Sebastian.
Yes, I am.
Or the other one.
Oh, okay. Sorry.
Still can't hear you.
Yeah, while he's getting the audio working, I'm definitely curious about this item since Rook today, we don't support taking over Ceph clusters, or we haven't tried to figure out how to document it or anything just because it's such a challenging problem to go install Kubernetes on all the nodes and then start Rook with all the assumptions we make about how we create an opinionated Ceph install.
Yeah.
Seems to be something very hard to do.
Yeah, I'm back.
There we are. Yep.
Yeah.
Okay.
Yep.
Perfect. Seems a bit very hard to do, right?
Yeah.
Is there any plan for it? Any existing thoughts for it? Nothing, right?
I was just saying, yeah, while you were rejoining, I was just saying that today, I mean, it basically means go install Kubernetes and then take over a cluster with Rook, whether it's Ceph or cephadm. I'm assuming it's a similar sort of problem. So Rook installs Ceph in a very opinionated way. And so if you're not within those opinions, it'd be really hard to take over the cluster.
Yeah.
What is the use case that you have in mind? Is to you have several nodes with cephadm containers with daemon containers that has been installed by cephadm, and you want to put in the same cluster a Kubernetes cluster to and to replicate the cluster with Kubernetes.
Maybe.
Why? my question is why somebody is going to want to do this kind of thing.
To get all the new bells and whistles. I don't know.
Yes, yeah. It's to use the same cluster that he's using for his production Ceph cluster, okay? And he's going to install Kubernetes in the same cluster and do the migration in the same cluster. I think that is not very realistic.
I think eventually somebody's going to want to do it, but probably not yet. Like if at some point it's clear that the best way to deploy a new cluster is with Rook, then people who have old clusters are going to feel that they should be able to have all the things that the new people have, right?
Well, I think that more probable is to start to think in a way to migrate information from one kind of cluster to another kind, or for example, to manage from a root cluster the external cluster. Okay, that in this moment is partially done. But
yeah, the external cluster support removes a lot of the pressure. I think actually cephadm will remove a lot of the pressure too, because you'll get most of the capabilities of Rook. You get like the Orchestrator abstraction and so on, cephadm, and so that'll release will be good enough, I think, for most cases. It also means that if we ever do want to do this conversion to Rook, we can do it only from cephadm to Rook, and then everything else is cephadm. And so if you really want to get from Puppet to Rook, then you can just do a 2-hop thing, which wouldn't be too bad. On the flip side of this, the way that the adopt stuff works, it has a style of deployment for anything that's not cephadm. And currently legacy is sort of the traditional varlib stuff, whatever stuff. It'd be pretty easy to add support for Rook wherever Rook is putting the data directories to the adopt. So you could take a Rook deployed cluster and adopt it into cephadm. Probably the hardest part would just be getting the initial, some of the initial keys out in order to start the first container. I'm not sure how much of that stuff is put in the etcd or whatever. But
yeah, if you were to hydrate some of that information, like the admin key and mon keys and things, you could probably get a long ways in a lot of scenarios.
Yeah, and the cephadm script would just run kubectl probably to just jump that stuff. Assuming you're running it in a shell and kubectl already works, you can just do it. It'd probably work fine.
Yeah, for external clusters, we need some of that information to be hydrated for us anyway. There'd just be some extra steps if you're trying to take over a cluster. Well, a lot of extra steps.
Yeah. Okay.
Okay. So adding host for Rook, Orchestrator, adding host new def host add for Rook. That really comes into a problem that we in Rook only have a specific set of hosts available, and that's not yet implemented for the Rook Orchestrator, obviously. So in which way do we want to implement that? Or do we want to implement that at all? Is it worth it to actually do host
in this case, it seems
manage?
like that means. Oh, sorry. Finish your thought.
So Kubernetes pods are runnable on specific hosts, right? And we could manage that from the orchestrator, even though that's, I don't know if we want to do that. And the option 2 is to actually add new physical hosts to a Kubernetes cluster.
That's option 1.
Yeah. I don't know. If we, what we want to do.
Does the second option actually make sense? Like, is there a case where Rook is consuming a defined subset of the Kubernetes cluster?
Yeah, so what I was going to say is that what I see this meaning for Rook is that, you've got a label where you want to deploy all your daemons or your OSDs or whatever. So you can have the labels on the nodes. So adding a node to Rook means, or removing it means adding or removing the label that's being used there. And then we would, for example, add OSDs onto the node where the label is just applied.
Okay.
Yeah, Rook isn't obviously going to be able to add new Kubernetes nodes. You have to do that outside of
inside of rook itself.
So I wonder, it seems like if you have a case where you have a Kubernetes cluster that has 100 nodes and rook is running on 4 of them, there's sort of 2 ways to look at it. One is where you do ceph-orch host ls and you see those 4 nodes, and that's the entire world from rook's perspective. And in that case, adding and removing hosts would mean adding some magic label that expands the subset of hosts that rook views as its world. The other way would be when you do orch host ls, you see all the Kubernetes nodes, and then you look at the placement for all the daemons, and you see that they're confined to certain labeled nodes in the cluster. Which is,
yeah.
And I'm not sure which one is, I'm not sure that one is strictly better than the other. They're just like different ways of viewing the same situation. But it might make sense to think about it in the context of how we want to think about host labels in general. I did spend a little bit of time last week trying to figure out how to do this, and I finally got to the point where I could like poke the Kubernetes API in this the right way, but then I didn't have the RBAC permissions to set or remove labels. But I basically had to pick a format for how to name the labels. They're sort of arbitrary. Like I was doing something like ceph.io / rook space label equals 1 or something like that. Can't remember.
Mm-hmm. Mm-hmm.
As in the way that the Orchestrator API views labels is it doesn't have a value, it's just a name, like a sticker, I guess. And the Kubernetes labels have values. They're actually matching based on a value. And it's not a set, so you couldn't have like, Orchestrator labels equals a list of comma separated labels or something like that. You have to have one per label.
Yeah, separate label per rook. Yeah.
But the approach we decided to go with is that rook is not the one setting the labels. Something else should be setting the labels. So in that case, maybe the manager could do it, but that shouldn't be done via rook.
I mean, that's what's happening, right? The manager just calling the API directly, Kubernetes API. But in order for the manager to map, a label equal foo or MDS or whatever, it needs to map into something like this, rook -namespace -label, which means we need to have sort of a prescribed whatever convention for what those labels look like, if we're going to be able to manipulate them from the manager.
Right.
And
when you say, sorry.
Right.
So when you have a host that you're adding, so you say host or ceph-orch host add, I guess what does that mean conceptually? Does that mean I'm adding a host that I expect any of the ceph daemons to be deployed on? Or is there a way to say this host is for OSDs and that host is for Mons? There's different labels? Okay, it looks like you're adding there.
Yeah, you can provide a list of labels as you add the host, or you can add them later.
Mm-hmm.
We'll add name.
Okay, Bluetooth really seems to be broken for me.
Oh, did we lose you again?
Oh,
we can hear you.
Yeah. Okay. Yeah, I think that's the way to go. To not net physical Kubernetes. I think that's out of scope for the Orchestrator implementation.
Mm-hmm.
You think so?
What?
Well, host add. I can see host add remove as being problematic, but the labels seem more reasonable because
What I think is that probably we will need to add some labels to some of the services in order to make more easy from the orchestrator to get information, to recover information, okay? But I don't think that really we have a need of managed host, because in Rook is something that is provided by the Kubernetes environment. Okay, so it's something that I think that we shouldn't do in the Rook environment. And for the labels, it's what I say. In this moment, for example, it's easy to get all the pods that are running, for example, RGW using labels. Okay, it's not the same that in cephadm that the label concept has been set a few weeks ago. Okay, so I think that we are using labels in Rook for all the things that we need in this moment. That probably it will be need to add new labels, but I don't see a real problem in this.
Okay. And it seems to be nothing that really is demanded by someone.
Yeah.
Except for the label management, maybe.
Yeah. I think host labels make sense. We could just pick some naming scheme. Label maps to
Yeah,
but I think that the sort of the bigger issue with all this is that we need to provide a mapping between the orchestrator placement spec and the Kubernetes placement. And it always works in one direction, and it only sometimes works in the other direction. So from Orch to Kubernetes, we can generate placement, added a spec, right? We can write a function that does this. Whatever a dict. Okay. And if we do this, if we have a defined mapping for what we need to have, like we have to support node list, if there's labels, we have to support labels, we have to support count. This one is a little bit weird because how the count is specified isn't a totally general thing. It depends on what type of CRD it is. So maybe this returns like a dict and a count options or something. I'm not really sure. And all nodes.
That's
or a host glob, right?
Yeah.
But to figure out how to but in principle, this is a function we can write that will take a placement spec. It'll produce something that you drop into your CR that does it.
And it's already partially implemented for the usual CRDs.
It's they only take the count right now.
Yeah.
Count is the only thing. Yeah. So I started to try to write this function, and I just didn't really know enough about how to properly construct the simplest. It's because there's so many different ways to specify things, and sometimes they're strict affinities, and sometimes they're like strong, and there's this like forced at scheduling but not at execution. I have no idea what that means. There's just all this weird stuff. But this seems like step one. That then step two would be to basically take whatever the Kubernetes CR is, which could be like who knows what, and try to fabricate a placement spec that reflects what it means. And it seems that like there, the initial step would be basically to make sure that any Rook CR that's produced by this generate function will give you back the same placement spec that you started with. So that at least if you go and you use the Orchestrator API to say, use this label, and then you go and you look at it, you'll actually see it, meaning what it meant. And then maybe it could try to be more clever with other common things that Kubernetes users do, if there is like sort of a meaningful equivalent. But then we have to be able to have some way of showing that we don't know. It's like a inscrutable, opaque placement, and we don't understand what it means. And so if you do like this, you do cephadm ls, you get things like that, or like what it should say.
We first have to discover that we cannot actually parse it properly.
Hopefully the more common cases we could parse it out of there, like node affinity uses this node label or whatever. Yeah, the placement is very flexible for sure.
Or do we need to expand the placement spec to add stuff that's usually used, or that's typically used by clusters? Is there anything that's often used by rook clusters that's not yet supported by the placement spec? Maybe we can add it.
Supported in rook, but not in placement spec?
Now, the placement spec is the recommended way to really configure rook. The other way is we have individual nodes you can list in the CR where we go look for those nodes for installing OSDs, but it's less preferred.
Link to the actual class.
We can link to the documentation.
List of hosts, count, and a host pattern.
Yeah. Okay. Anything? Do we have a conclusion? I think it does make sense to have it, right? If we really want to support rook clusters from the dashboard.
Yeah, sounds good.
We want definitely these first two. Want to be able to parse anything that we generate, and show when we don't understand, and then feeling generous, then we can do the other stuff.
Yeah, I guess rook also has the ability to apply the same placement to all cephadms, or you can do it by individual cephadm.
Mm-hmm.
What else?
Yeah, I think that matches.
Yeah.
Okay.
Well, and Kubernetes also has a concept of taints and tolerations, which might need to expose, like, oh, you want to run on that node, it's tainted, you better add this toleration. Or maybe we just take care of that automatically if we find a tainted node that they've selected.
Yeah.
Okay, next topic. Recover OSD remove.
Yes. Again, okay. We need that in the orchestrator layer, okay. and it's something that has been removed in the rook part, okay? And I think that, well, the reason for remove this functionality was only just to stay safe, no, and to avoid to do operations that could finish in data lost. Okay, so well, I think that is not enough. That reason, okay, we should provide the functionality, and it's something that I think that everybody expects to have, for example, in the dashboard. So I know that it was a discussion about this point, and it was decided to remove the functionality, but I think that it's something that is not a good idea to maintain.
Yeah, and we already have a lot of that, right, Sebastian?
Joshua added a new manager module to the module to the manager to help with Osd remove. I think that's the way to go for Rook.
Right, so that helps you with draining the data of the Osd, so that you only have to do the various bits like removing it from the crush map and then eventually zapping a disk. So the necessary steps are not that hard.
Let me find a link to the source.
That device zap already exists.
Yep, it's implemented for cephadm. It's not wired up for Rook.
Got it.
But it's just a one-time. Like you could, if you do ceph-orch device ls, and you see a device and it says available no because it's owned by current cluster or whatever, you could then run zap on that device, refresh, then you can provision it. And Joshua,
internally,
I think,
that's using ceph volume though.
Yeah, right. So maybe this is just a matter of adding that for Rook.
Yeah, I think so, yes. We need to implement the primitives. And then that needs to be implemented.
And then for this safe Osd removal, I wonder if it makes sense to have Rook use that. Like it probably has its own draining stuff when it's trying to remove an Osd, or maybe it was removed. But
yeah, we don't remove Osd anymore.
Yeah.
Okay. So if you're going to add that back, then it should just call into this command and let the manager do it.
Well, the problem is that Rook by itself should do all the tasks without the need of the orchestrator. Okay, I think so. We can use that, but it is going to work only if you do the command using the ceph orchestrator, the manager orchestrator. I think that we should implement all the logic inside Rook. I think that it was.
You could still leverage the Osd module because that's a manager module, and you don't need to have the orchestrator itself. So the draining part, so the schedule, so you can schedule multiple OSTs to be drained, and then you can query the status using that manager module. So no orchestrator. So the remove logic can still live in Rook. Right.
And I mean, Rook already makes use of lots of ceph commands, so why not using this one?
Right, so I think I still think the manager modules are the right place to drive the OSD removal. The rook itself, being or working on desired state. What we're doing here isn't really desired state. It's more of a one-time operation, or so the module just seemed like the place to drive it.
Yeah. Not sure. I'm not sure there's a need to do it from rook.
The thing is that you need to target specific. So you need the resolution of where is that OSD ID that you want to remove located. So you need to create a map, but you can get the information from the OSD map, I think, from the crush map. But then you have to send out a command to the specific host saying remove that or zap that disk. Therefore, it, at least for cephadm, lives in the orchestrator in cephadm and not exclusively in the module.
Right, and I guess the rook orchestrator module could drive that.
Yeah.
Right, instead of the rook operator, I guess.
Okay.
Yeah, and soon we will have the logic to run jobs to wipe devices. So we could potentially have a similar job being triggered. Yeah.
Okay, it's good detection to follow.
Okay. Anything else regarding OSD remove? Okay, upgrades. Sage.
So there are a couple commands that let you trigger upgrades from the Orchestrator API. You can either pass a ceph version, sort of what mostly encourage people to do, or you can pass an image and a tag. The version just maps to an image name, although the base image name is configurable. So in the end, it's taking the same code path either way. So I think the start is trivial to map onto rook. Like you would just go update the CRD to change the image property of the CR, and then you'd be done. Rook would go and trigger an upgrade, right? On the other hand, there's also upgrade stop, which will cancel an in-progress upgrade and just sort of leave the cluster right where it is. And there's a status that will query it. And I think those don't map onto how rook behaves. Maybe these just return implemented error. Rook. I don't know. Makes sense.
Right, we've talked about upgrading that feature too, so maybe we should just go do that.
I mean, upgrade status, we can have a look at it if we just compare which pods use which image. And that would provide us with how many pods are still using the old image, but also how many pods are using the new image.
Mm-hmm. Yeah, I think that the difference is that, it's stop that doesn't make sense, right?
Yeah.
Because cephadm, you can stop it in the middle and it sort of carefully records the current state along the way. And so when you stop, it's in a stable point, and restarting stuff doesn't actually upgrade or downgrade anything again, doesn't revert. When I actually go back and downgrade, you upgrade down to the old version. Get everything back in the same version again. It'd be nice to actually have a progress item too. I mean, I wonder if status doesn't really make any sense because it's not, you can't stop it anyway. I guess you can just show that it's in progress. It isn't actually fully upgraded yet. Yeah, I guess that makes sense.
And to see the upgrade progress, I mean, do we just need to see how many daemons are on the new version, or what type of progress would help?
That's what the cephadm one does. The progress bar is just number of daemons, how many are on the right version and how many aren't.
Mm-hmm.
Okay. Anything else regarding upgrades?
At some point for both of these, we need to support the major version upgrade, but I think we can kind of kick that can down the road until the end of the Pacific cycle when we actually need to upgrade from Octopus to Pacific. And that'll be the first one.
Upgrade from Nautilus to Octopus is implemented in Rook itself.
Yeah. Okay.
That's right.
Okay.
And I don't know, probably will need it in Rook for Octopus to Pacific anyway. So it might be something just for cephadm.
Can you do a downgrade, Travis, in Rook? If you just specify a container image that's older, does Rook know or care? Or will it just go restart everything?
We refuse. No. We don't allow it.
There might be a workaround if you restart the operator, but yeah, that's about it.
Okay, so the plan is to, right now, cephadm isn't checking anything. It's just finally doing the upgrade or downgrade. The plan is to add tests to the QA suite so that we're testing downgrades within the major release. So we're going to randomly upgrade and downgrade between point releases in Octopus. So maybe the thing to do in Rook would be
minus
to
one
match
only.
Not even that, just to allow minor jumps between minor versions, but not major versions.
Yeah, but like minor one version, right? Minus one of the minor version.
Just between any patch release?
I think between any patch release was my thinking.
Okay.
I don't know that we have any reason to make you step between them carefully.
Okay.
And with Octopus, we can release that, or that's a Pacific thing?
Yeah, well, we should add the tests first, but
Right.
that's the plan. The plan is to test it. Yep, and once we test it, then we can let people do it. So, yeah.
Okay. Any other discussion items for today? I don't think so. I think we are done. Do we want to quickly go over the priorities for cephadm and for Rook, for the Orchestrator Rook implementation, or for Rook itself?
Just ordering this list?
Yeah, a bit ordering this, a bit, yeah. Stuff that's really needed versus stuff that's optional.
Yeah. I need to drop now for another meeting, so Seb can represent Rook, and I'll talk to you later. Thanks.
Okay.
Thanks. Yeah.
So in cephadm there are still a lot of rough edges, and I think we first need to really make sure stuff is working properly, stuff is streamlined, and I think that should be the main focus for Pacific right now. So that includes LGW and FS monitoring, Osd replacement, etc. Minor upgrades. LGW multi-site.
Just one thing, Sebastian, that will include the error path testing as well, because I think that's an area that really is going to be concentrated on what happens in all the varying error modes and recovery mechanisms. So hopefully that's part of the first one.
Yeah, I think so. Yep. Rook uses. Also like large scale clusters.
I think we are mainly talking about OSDs here.
They're just scraping. Like if you have 100 nodes, the scrape process might take a while. That sort of thing.
Yeah. But that's just taking longer to actually refresh data. I think that's okay. But we need to also deploy OSDs on all nodes in parallel, or at least very parallel, not looking at each node in at once. Yeah. What about LGW multi-site? Anyone wants to take it?
I think it's mostly already there. It's actually a matter of changing the documentation to use the Ceph orchestrator commands. I think the orchestrator pieces are all there. You just have to like set the configs. Cephadm just starts the daemons.
Okay.
Unless we want to, at least for cephadm that works. For Rook, it's going to be trickier because Rook is going to have CRDs to express this stuff, and we need to figure out how to map, align, whatever, keep these things working. So I guess there's more to do there, but at least for now, you can still do it. You should be able to do it.
In Rook, I think that in this moment, Alice is working in this, so we are depending of this.
Yep, agree.
Okay. DM crypt on the top of the list right now. Telemetry. QA in general is a big topic.
Sebastian, do you have an opinion on how, or anybody else, on how we should be doing the containerized client workloads? Like, should we just have a Ceph container image that has all the debug packages and all the tests installed? That's just, like 2 gigabytes or whatever it is. Use QA tests? Yeah. Yeah, you said. Yeah.
Oh, okay. Yeah, I think we have to have an image like this with packages that have all the labels and everything. Yeah, so we can probably pull it. These are this, Ceph debug with labels, everything, like the non-compressed.
Do we want Ceph test debug? Because one of them, this could just have plus debug info. This one is plus Ceph test. All the other random crap.
What about?
You could go all in one, I guess. The debug image, like the standard debug image, that would have all the utilities, everything.
Yeah. That's fine. Do you want to do that, Seb, or somebody else who understands how the Ceph container works?
Yeah. Okay. Yeah, that should be easy. Yeah. Okay. I'll take this one.
Awesome.
To demonstrate, I guess.
Yay. Yeah. Cool.
Yeah.
Okay. Improve developer experience for cephadm. So right now, at least cephadm itself is one big file. I think many thousands lines of Python code. And then we have restart with cpatch, right? Would be great to have improvements here, even though they're not really features, right? But
Yeah.
We have to also look at the developer experience, and instead of just only focusing on features and stuff.
Yeah, or even just a pure cpatch thing where you really build, patch your container, and then bootstrap. One too.
Documentation for cephadm. Yes, Sage?
Nothing. That's all.
Okay. Documentation for cephadm. I think it's still lots of improvements can be made there. Especially the CLI documentation really is still outdated. Diffs, yes. But what about more advanced scheduling algorithms and resource limits? Is this already something for Pacific or something after Pacific? Depends a bit on how good the current algorithm works, I think.
Yeah, I mean, it's purely random right now. It could be improved slightly so that it just like picks the server with a few daemons or something like that. But I don't think it'll be too long before people want. So, I don't know. I think this would just be a wait and see how far along we get. And if we haven't reached Pacific yet and we're out of other stuff to do, then we should do it.
Yep. File-store adoption, I would do it only if someone really demands it. Has a demand for it.
Yeah.
Exec-neg. It's really in maintenance mode. That's the base for Remoto. It works right now. The question is how long? And are we going to head into trouble if we don't do anything? Who knows?
Yep.
Make Ceph disk a better experience? That's definitely on the list.
I think if somebody demands it.
Yeah.
Just like FileStore.
Stay alive mode? What does it mean?
Yeah, I just wrote this one. I was wondering if you had a mode where if a daemon keeps crashing, then you could force it to actually stay alive. So then you can get it to that container and get the exact same context, the same environment, and then start debugging.
There isn't, but you can look in varlib stuff, FSID name. There's a unit.run, which is a bash script, which is just the podman command that runs the container. So you can just cat that file and edit the line with whatever extra options you want, like get rid of RM maybe, or whatever you want to do. You can always run all these. You can always run the daemon manually.
Because typically what's really difficult for people when doing troubleshooting is to get into the exact same environment as the container is just before crashing. For example, they might have no idea what the bindments are or things like this. And even though you remove -rm, then the container is already gone. So the idea is really to maintain it alive using whatever mechanism.
So the complete environment is in that unit.run bash script. And you can just also run it interactively if you want to.
Okay, so it's just removing and adapting the unit file or something like this?
Yeah, I mean, this isn't the unit file. This is a bash script. Right? This is the bash script that the unit the systemd unit runs.
Oh yeah, and then it has the container context as well.
So you just do systemctl stop, so it stops restarting, and then you just run that directly, or you cat it and edit the command, and then paste it into your terminal to run it. Whatever.
Okay, and then you remove the cephadm line and you put in sleep infinity, and then you could just get into that.
Whatever. Yeah.
Okay.
Yeah. Yep.
I guess it would be nice to have a more elaborated and more elegant way to do that.
Yeah. Yeah. I mean, if it hasn't exited yet, then it's just cephadm enter -- name.
Yeah, of course. That's the easiest one.
That's easy.
But if the daemon crashes and then you want to run things manually, you want to add your --debug before running it, and then get a more like pleasant debugging experience.
So far, just catting this file and pasting the podman command has been enough for me every time I've needed to go check.
Because you know how it works. That's my point.
Yeah.
I think the unit.run path is also documented in the official cephadm docs.
Yeah, we could add a note there. There's a troubleshooting doc. Can't remember if it mentions that you can run this manually or not, but you can add it there. I think the most frequent problem I have with this is that on my developer box, my root partition is not that big for some stupid reason, and it keeps filling up with either just container images that don't get deleted automatically because I'm constantly launching the master container, which updates like every day, and or I leave a test cluster running, and it's logging all this crap to the whatever the standard error, and that's in some file in varlib containers thing. There's a file where all those logs accumulate, which is super annoying. I don't know if there's a way, if we should be doing something like, does Kubernetes go through and do like Docker rm-a periodic or RMI-a periodically just to clean up old images, or like what? Is there some garbage collection policy?
I think there's some garbage collection, yeah.
Okay. Is that something that Kubernetes does, or does like just Docker do it on its own?
I think it's the kubelet that does this, calling cryo and just doing it.
Okay. All right.
Just make it a track issue for that.
Yeah.
Okay, Rook. It's not yet really ordered. Placement spec, host labels, upgrade status. Keep aligned functionality with cephadm, and that's upgrade status. Integration tests.
Sorry,
there was
one thing. The order is the priority.
Yeah.
So I think that in this case, it could be nice to have integration test in the first place. Okay. And now what we have is just, I have started the test in using the integration environment that we have in Rook. Okay. But I think that it's important to have all the integration tests with the whole, all the coverage for all the functions. Okay. Because, there are some things that are not working, and it's just because are not tested. Okay, so we need to have this in place as soon as possible. It's my opinion.
Yeah.
Okay. Yeah. So having no real integration test of rook and ceph was really a major pain for Octopus for me.
Well, basically we have the basic structure, okay. I have started to make the test and to fix things, okay. And I think that we are not too far from have this complete coverage of the test. So I will continue with the effort in this point. I think that it's essential to have the integration test, and after that we can continue adding functionality.
Mm. Osd Management. Is it more on top of the list? Or Rook?
I don't know. It seems like the OSD, we should make it so that the OSD remove works. Like ceph, orch, the RM, implement just enough in Rook so that it can properly deprovision an OSD. And then we should also implement zap. Feels like if we do those two things, then everything else will be built on that, right? We can create new OSDs, we can destroy old OSDs, and we can zap devices. Rook doesn't need to do anything clever there. It just needs to have those little.
Is zap necessarily part of remove, or is that a separate option?
Separate option. At least the way it's currently implemented. I think makes sense.
Yeah, it's good to have a retain policy if you do RM, I guess.
Yeah. It's a little bit weird. I think there's this sort of loophole right now where if you go and you delete an OSD, and you have well, I guess there are two of them. Like if you remove an OSD, then if you go list the inventory, you'll see it's still there because it wasn't zapped, and Cube or Rook will recreate it. I think, right? It just sort of instantiates pods whenever it sees devices.
It depends if you had activated that option or not.
Okay. So that might be one thing. And then there's a similar thing where with cephadm, if you have a drive group that says, create OSDs out of every hard disk, and then you go and you delete an OSD and you zap it because it's a dead drive and you want to replace it, then it will go and create a new one immediately. But maybe the answer there is just not to zap it.
Well, it will only, in order to get that prepared pod running again, you would have to go through a new orchestration, and that orchestration is not triggered automatically. It's only triggered if you have that special mode where we look at UDEV and then we search for add events, and then we trigger an orchestration. If you don't activate that, then you don't need it. So it's hot plug in the operator settings, and it's false by default. So yeah, it should be good.
Okay. Well, in any case, OSD replacement, I think, which should be on there.
Yep.
Yeah. And OSDs on PVs, sure. I think if and when somebody shows up and wants to do it, then they should do it. I don't know how important it is. This other stuff feels a little bit more important to me.
Okay. I think we're done.
Yeah.
Yeah.
Awesome. All right.
Okay.
Thanks, everyone.
Right. Yep.
Have a good one.
Bye-bye.
Bye-bye.
Well,
Bye.